Well, good day. In Geometry Gold Group Friday session, we'll be going over Geometry CO3, applying the midpoint formula in various contexts. And we're actually going to start with a coordinate plane. You don't have this in your binder, so don't worry about jotting anything down just yet. But let's say that we've got a segment at -4, 3, and 2, 1. Okay. Ooh, I'm so bad at drawing lines. I think I was gone that day in kindergarten when we did connect the dots. All right. Tell me what the midpoint of that segment is. What is the midpoint of that segment? Just kind of look at it. Kind of take a guess. Yeah. 1, -1. And what makes you say that? What do you mean by it's not in between anything? Yeah, right. It's got integer coordinates, right? It's not like it's not passing through the side of a unit here. It's passing through a corner. It's -1, -1, no decimals, no fractions, anything like that. Okay. Why else does that stand out to you as the midpoint? Yeah. It looks like it's in the middle, and we've talked about how it's dangerous to say it looks like in geometry, but there's actually a couple things that we can do here to back this up. Okay, think back to last year. When you graphed equations on the coordinate plane, what were some things that you used or talked about or calculated perhaps when you graphed those equations on the coordinate plane? Characteristics, maybe? Slope. Excellent. Slope. What is slope? What is slope? Rise over run, how a line moves across the coordinate plane. What is the slope of this particular segment? What is the slope of this particular segment? That change in y or change in x, all those things are correct ways to define slope. Yeah. Okay, so if we start here at our end point and go up 2 over 3, notice we end on that midpoint. And what happens if we go up 2 and over 3 from the midpoint? Up 2 over 3. Look at that. We end on the end point, right? So using slope, we can say that yes, that is in the middle of the segment because we do the same thing to get there, then we do it again and we get to the end of it, right? If you said the slope of this segment is 4 over 6, starting here and going up 4 and over 6, you'd end right at the end point there. But what is the fraction 4/6 in simplest form? 2/3, right? And that's why we have the 2/3 that we have there, okay? So there's definitely a relationship here between slope, things you've done before, and now this new thing of the midpoint. So let's go to our binder sheet now, and let's define midpoint. We kind of already have, right? It's the point in the middle of a segment. Okay? The point in the middle of a segment. Going back to what we know about segments and rays and lines, you can't have a midpoint of a ray. You can't have a midpoint of a line. The one argument to that might be the number line. 0 would be the middle, but you got to be dealing with a segment here, a beginning and an end. Okay, and when we talk about midpoint, we're going to focus on, is it halfway? Is it the middle? We're going to focus on the average. Okay, because it's the average is the math behind the midpoint formula. So the midpoint formula says that we're going to take the average of the x values and the y values of our endpoints. So if we have endpoints of x1 and y1, do you remember using x1, y1 before when calculating slope? So you know that this is not an exponent, right? It's not 1 times x or our second x point is not 2 times x. It refers to the first x value, the first y value, the second x value, and the second y value. And what the midpoint formula says is that if you take the average of those points, so we're going to take x1 plus x2 and divide by 2. So that's how you find average of something. You take the sum, then divide by how many there are. The average of the x values and the average of the y values, so similarly here, y1 plus y2 divided by 2, that ordered pair is going to be the midpoint. x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Everyone have it? Okay. So let's go back to our coordinate plane here, and I'm going to write this formula up again. Okay, and let's apply it to the midpoint and the endpoints that we have here. The endpoints of this segment, we've got -4, -3, and the other endpoint is 2, 1. I strongly recommend, since you're learning this for the first time, going ahead and labeling x1, y1, x2, y2, just so you have those values. Yes? Not yet, not necessarily. Right now, I just want you to absorb. Okay? If you want to write it on the back side of your page or whatever, that's fine, but not necessarily yet. I just want to prove to you it works. So applying the formula here, we are going to take our x1 plus x2, which is -4 x1, plus x2, which is 2, and divide by 2. And then for the y value of the midpoint, we're going to take y1, which is -3, plus y2, which is 1, and divide by 2. Okay? -4 plus 2 is -2. -2 divided by 2 is -1. And then -3 plus 1 is -2. -2 divided by 2 is, again, -1. The exact same ordered pair that we found earlier for the midpoint. So the formula does work, and we can see it here. And if you're asking yourself, well, it was a lot easier just to use the coordinate plane and look at it, why do we need this formula? Raise your hand if you carry around a pocket coordinate plane with you. Only nerds do that, right? Mine's my back pocket. Okay. But anyway, so if you're not given a coordinate plane, if you're just given 2 ordered pairs, like we are here, the formula comes in very, very handy. Otherwise, you have to make your own coordinate plane, and then you run into accuracy issues, space issues. If you're dealing with like -17, -31, that's really far away from the origin. It's going to be so. The formula definitely has its advantages. So let's practice this with points A and B that we have here. I'm going to go ahead and label these x1, y1, x2, y2, just so I don't forget. And using this formula, I'm taking the sum of my x values, and this actually coincides perfectly with what we're doing in algebra in PO3, right? You've got x1, which is 2.
Teachers, I have a very last minute but important request. I need...
All right, so where were we here? Okay, so x1 plus x2, -2 or +2 plus -5. In algebra, we are talking about, adding a negative number, right? And here we see the application of that. The plus sign, being part of the formula, has to be there. And then the negative sign that belongs to the 5, our x2 value, has to be there as well. So if you were wondering in PO3, when am I ever going to see 2 plus -5? Why would you write it like that? Why wouldn't you just write 2 minus 5? Here's where you would see it. When you're using a formula with negative values to get to a result, you now understand what this really means, 2 minus 5. Okay? And then our y values, y1 plus y2, we've got negative 3 plus 6, and we are dividing that by 2, and that is going to be the midpoint of the segments with endpoints A and B. 2 plus negative 5 is negative 3. Divided by 2 is negative 3 halves. That's what we get from the x part. The y, negative 3 plus 6 is positive 3. Divided by 2 is positive 3 halves. So we have negative 3 halves, positive 3 halves. Okay? Questions on that? Audrey?
So you wouldn't divide it, or?
If you want to write negative 1.5, positive 1.5, that's fine too. I said earlier that as we move further into the maths, we use fractions more and more, particularly improper fractions. The reason why is because if you were to get an answer like 5/7 and you divided 5 by 7 into your calculator, the decimal's long, you don't want to write the whole thing, what are you going to do? You're going to round it, right? But what happens to a value when you round it? What do you lose? You lose accuracy, right? And particularly if you use that value again in an equation later on that you've already rounded, the more you round stuff and continue to use it, the less and less and less accurate your answer becomes. So by leaving answers as fractions, such as 5/7, that's the exact value of it. You use that again in another equation, it's going to keep the value to be accurate. Thank you. Something like this, though, that ends, it's 1.5. I mean, you don't have to round it. Then you can write the decimal form there. So the less rounding, the better. Yes?
So are both negative 3 halves and 3 halves the midpoint?
Well, the midpoint, remember, is an ordered pair, which means it has an x coordinate and a y coordinate. So the x coordinate of the midpoint is negative 3 halves. The y coordinate is positive 3 halves. Okay? Don't do this on your page because we'll use this coordinate plane for something else. I wonder if I scroll down, what's going to happen to my ink? It's going to scroll on with me. Okay, perfect. Anyway, so let's, if we were to, I don't know where I'm going. If we were to plot endpoints A and B on this coordinate plane, they were what? 2, negative 3, and negative 5, 6. So 2, negative 3, right here. Negative 5, 6 is up here. Okay. This is that segment that we just solved for the midpoint for, plotted. The midpoint of this is at negative 3 halves, positive 3 halves, or negative 1.5, positive 1.5. Right? So it's a location. So it's not that these are both the midpoint, it is the midpoint. That's the x value and the y value of one point that is in the middle of the two endpoints that you were provided. Make sense?
Yeah.
Yeah. Okay. All right. Other questions on that? So your homework then, in part, is to do the second one that we didn't do. Then also this section here with the coordinate plane. It says, surely there's a part of you that has always wanted to be an architect. Design a town on the coordinate grid below. Your town should include a library, L, a church, C, a school, S, and a city hall, H. So our library, you can go ahead and plot these points. Our library is at 3, 6. Okay? That's point L. Remember, in order to pair the x value, the horizontal always comes first. Okay, so 3, 6. The church is at negative 9, 4. Plot that there, point C. School at 0, 8. That's up there. And City Hall, point H at 5, negative 4. Okay? And then you've got some questions to answer here. The first one, what is the midpoint between the library and the school? Okay, so the library, recall, is at 0.36. The school is at 0.08. and you want to find the midpoint between them. Now, I did not give you a coordinate plane so that you can find it just by looking at it. Okay? I want you to use the formula to calculate the midpoint, plot it on the coordinate plane, and then verify that, yep, that looks right about where it should be. It looks in halfway between the school and the library. So going ahead and doing this one together, x1, y1 for 3 and 6, x2, y2 for 0 and 8. Our midpoint is going to be x1 plus x2, 3 plus 0, divided by 2. And the y-coordinate is going to be y1 plus y2, 6 plus 8, divided by 2. Again, all we're doing here is finding the average of the x's and the average of the y's. We again get 3 halves as an x value, 3 over 2. And for the y value, 6 plus 8 is 14, divided by 2 is 7. So then you take that point, and you'd go ahead and plot it, 1.57. And does that look to be in the middle between the school and the library? Yes, it does. So you would know that you did it correctly. If you used the midpoint formula and you plotted the point and your point was somewhere over here, okay, that's not in the middle of the school and the library. That's why I give you the coordinate plane, because I want you to plot the point and verify that it's in the right spot. Okay. So, yeah. Questions? Yes.
How did you graph 3 over 2?
I took the decimal value, which is 1.5. So on my x-axis here, 1.5 is halfway between 1 hole and 2 holes, and then I went up to 7 and put the point. Yep. Yeah, when you're actually plotting it, probably decimal values are better to work with, just because they're easier to visualize. But so then your brain buster down at the bottom, it says, what is endpoint B of segment AB with endpoint A at negative 10, 6, and the midpoint at 14, negative 2? So in every other example thus far, you've used the formula being given both endpoints to find the midpoint. Here, I'm giving you one endpoint and the midpoint and asking you to find the other endpoint. Okay? So you have to think about, how am I going to use this formula to find the other endpoint of this segment? If I know one end in the middle, how do I get that other end? Questions on this? Okay, on to CO4, but first, that's how you math.